Hi guys, welcome back to the channel. Hope you all are doing well. Today we're going to be designing a newsfeed system. When you think about newsfeed, think about applications like Facebook, Instagram, or Twitter. All of these applications have some kind of a newsfeed where you can go and browse through all the different posts. The posts can be either video or photo posts. In our case, the system we're going to design is going to be more similar to Facebook, where a user can have multiple posts. To keep things simple, we're gonna only think about posts with photo, even though video posts are gonna be pretty similar in design, so you can easily extend what we talk about in this video to a feed system with videos, right? We are gonna be starting with the basic requirements that you see over here, and then gradually we're gonna build our way to this final diagram that you see in this slide. Of course, it's totally okay if a lot of these diagrams does not make too much sense right now. We are going to start from the functional requirements and then gradually build up to this version that you see over here. As we add different components to the system, we're going to talk through all the different trade-offs, the pros and cons of the system, and why we're choosing one technology over the other. Alright, so to begin with, we are going to start with the two high-level requirements that we want to find a system design for. The first requirement is the one you see at the top. This is going to be a user opening their app and deciding to create a post, and we need to figure out how to store this post in our backend. For the next requirement, the one you see at the bottom, the user will go to their feed, and we're going to show them a feed composed of posts from all the friends that the user has. Once again, to keep the use case simple, we are going to be talking about photo posts only. We're not going to be including video posts. So yeah, that's going to be the two requirements. One is going to be creating the post. Another is going to be going to the feed to consume multiple posts. So the first question that comes to our mind is going to be the data model, how you want to store the data when it comes to both the user data and the post data. So to start things off, we are going to keep things simple and go with a bunch of relational tables. When I talk about relational databases, what I mean is it can be MySQL, Postgres, or anything with a simple table structure. Of course, you can talk about having a NoSQL database or some other kind of databases, but we are going to talk about that later on. But to begin with, to keep things simple, we're going to start off with just some basic MySQL tables. The first table I have is the user table, which is going to store all the information about a user. In the green box over here, you can see the different columns that the table is going to have. So for the user table, we're going to have an ID, which is going to be auto-incrementing, the name of the user, the avatar URL. So this is going to be just a picture of so essentially the profile picture of the user, age, gender, and location. I'm keeping things very straightforward because the whole idea is to construct this full end-to-end system rather than focusing on individual components like the schema of a table or things like that. The next table we have is, of course, the post table. This is going to be all the posts coming from all the users. In our case, the post is going to be very simple. So we're going to have an ID, headline, description, and the image URL. And then we have the friend table. This is going to be a very simple table which maps a user ID to all the friends that the user has. So for a given user, it can have multiple rows with the different user IDs of the friends. And finally, we have the post user table. This is going to be a mapping between the user ID and the post ID, which is going to be an ID from the user table and an ID from the post table. And this is going to be the mapping between a post and the owner or the creator of that post. So that's going to be all the tables that we need. Of course, in a system like a newsfeed, it can get very complex and you can have multiple data warehouses, data lakes, or even other NoSQL databases. But in our case, to keep things simple, we're going to start off with some basic relational tables. All right, so now that we have an idea about all the different database tables that we have, let's think about an end-to-end flow of what happens when a user creates a post. We're going to keep things simple and then gradually add things on top of it. This is going to be the template for all the system design videos, even the ones that I published before. In all of these, we start from something basic and then gradually build our way to the more complex and optimized version. All right, so to create a post, the first thing the user has to do is, of course, open the app, which is over here. The user opens the app and then goes ahead and creates the post. Once they create the post, the first thing the front end would do is hit our load balancer. The load balancer is going to figure out which API server to hit. And then our first microservice, which in our case is going to be called the post service, is going to be hit with a post request. The post request, in the request body, it's going to have all the data about the post, so the post headline, description, and image. All that the post service is going to do is go ahead and persist the data in our post database and also the post user table, which maps a user to a post. So essentially the backend server is going to go ahead and store the post in this post table, and then also the post user table. Okay, so let me just make sure, yeah. So that's going to be the first end-to-end flow. Very simple. All we're introducing is a load balancer to distribute the request load between the different services. And then we have our first service, which is going to be the post service, talking to a MySQL database. All right, so now let's talk about some of the more additional work that can happen behind the scenes when a user creates a post. So we're going to start from left to right. The first step is going to be the user goes ahead and opens an app, creates the post, it hits the load balancer like we talked about in the previous slide. The load balancer figures out that it needs to hit the post service with the request, and it does that. And the post service goes ahead and stores the new post and the user post mapping to our two relational tables, post and post user. Now, when it comes to creating a new post, of course, in your system, you want to do a bunch of different things, right? One of them might be moderating the post. So let's say you want to figure out if the post has any bad content, because of which you want to delete the post or just not promote the post anymore. You can also have things like post enrichment, which is going to be extracting different metadata or running different algorithms on the post to figure out more details about a post. For instance, the photo can have different features that you want to extract or do a bunch of different things. And let's say you want to do those processing and store the data in a different table called post metadata or something. So let's see how you want to do that, right? So of course, you could make an argument about doing all these work. So the work we talked about over here, you can make an argument about doing all these in the post service. But the problem with that is you make the HTTP request that the front end is making blocking if you do it that way. So then all these things, which might take much longer than just storing the data in the MySQL table, you don't want to do all those things as part of the HTTP request coming from the front end. You can easily do all these asynchronously in the backend so that your client does not have to keep on waiting. All right, because all your client cares about is making sure that the post is persisted in our primary database. Doesn't really care about if all these things are happening too, along with the first step. So the way we're gonna make the whole thing asynchronous is we are gonna introduce a CDC stream. So all databases, especially MySQL or relational databases, have the concept of change data capture. This is gonna be in our case, I have Kafka over here. So this is going to be a Kafka topic where a message is written to every time a row changes in the relational tables over here. That means, let's say whenever a new post gets created, or a post gets updated, or even a post gets deleted, there is going to be a message in this Kafka stream over here. And the message is going to have all the information about the new row or the updated row as well as the old row. So essentially, one message is going to have enough information about a new post that has just been created. And then you can have different consumers of this Kafka topic, which is going to independently do different actions on the post. Let's say you can have a moderation stream processor. This is going to be consuming from the CDC stream. And for every message, all it's going to do is run some algorithms on the post data to make sure that the content is not something that is illegal or inappropriate for the users. Similarly and independently, you can have another stream processor, which is going to do all your enrichment. So this is going to take in the post once again from the CDC stream, and then run a bunch of algorithms to extract different features and different details about the post. And then maybe it can store it in a post metadata table or something like that. But all the things that's happening to the right of the database table, all of these are asynchronous, so your client does not have to keep waiting for these. That's why it's totally okay if these processes are taking longer, because it's totally fine to have the whole thing happen asynchronously. All right, so that is going to be the end-to-end flow of creating a post. So as you can see, the only thing that's blocking is us storing the post in our primary relational tables. Once we do that, we give the response to the client and the client can move on with their day. In the backend, we have this Kafka CDC stream, which kind of decouples all the other consumers that needs to take different actions based on whether a post has been created or not. And given the decoupled modular structure over here, you can easily add as many consumers as you want, and each consumer can do different things based on the post that was created. So decoupling the asynchronous components from the synchronous components gives you this benefit of doing things independently. All right, so that was all about creating a post. Now let's talk about how you can consume posts in a feed, right? This is going to be your second use case where, let's say, a user opens the app and now they want to go to their feed and look at all the posts that their friends have created. The first thing you do is the client makes a GET request to the feed endpoint, maybe with the user ID. It hits the load balancer. The load balancer knows which service to hit. And the first thing it does is it hits our feed service. Now this is a new service that we have. Previously, we only had our post service. What the feed service does is it's going to have all the endpoints and logic related to creating the feed for a given user, right? So this is going to be, let's say it's going to take in a user ID. It's going to compute all the different posts you want to show to this user in their feed. And then it's going to give the whole feed as a JSON payload back to the client. So the first thing that the feed service is going to do, it's going to get the user ID from the GET endpoint. And then using the user ID, it's going to figure out all the friends that the user has from the friend table. Once it gets all the friend user IDs, it's going to talk to the post service and tell the post service to give it all the posts related to all the friends user IDs. At this point, the feed service should have all the posts created by the user's friends. And then the feed service can call the ranking service with all the post IDs. The ranking service is another new service. What it does is essentially, given a list of post IDs for a user, it can do a bunch of different rankings. So it literally just like sorts, filters, depending on different logic. All this logic is going to, of course, reside in the ranking service. And then the ranking service is going to give the feed service a list of posts in the correct order that should be displayed in the feed. And then the feed goes ahead and sends everything back to the user, right? So essentially we have 4 steps. The first one is the feed service getting the user's friends. The next one is the post service taking in the friend IDs and giving back all the posts created by the friends. The third step is for the ranking service to rank all these posts given different sets of conditions. And finally, the fourth step is for the feed service to give the JSON payload back to the client so that they can display the feed. So that's going to be our first simple version of how the feed system is going to work. But of course, this is going to come with a bunch of problems that you can already see. The first one is the workload on the feed service is going to be quite extreme. For every time a user loads a feed, the service will have to make all the different HTTP calls we talked about, interact with all the different services, form this whole payload, and then send it to the client. Similarly, even the post service and the ranking service, their job is gonna get quite difficult because they would have to do all these computation every single time a user wants to go to their feed. Of course, you don't want that because not only do they involve a lot of different HTTP calls, but they're also causing a lot of database queries. So every request is going to involve like 3 or 4 HTTP calls as well as 3 or 4 DB queries. Combined, this is going to really affect the response time for a user to go to the, when it comes to the user going to their app and the feed showing up. We don't really want to do this. Somehow we want to pre-compute everything so that when the user is ready to see the feed, everything is already computed for them ahead of time. So that's where our cached solution comes in. All we have done over here is taken the feed the feed service and added a layer of cache near the feed service. So now what happens is when the user wants to get a feed, they make a request to the feed endpoint. The load balancer forwards it to the feed service. And now the feed service has a local cache. We're going to call it a feed cache. It can be anything. It can be a memcache, Redis, or some kind of caching system that you're familiar with. What the cache is going to contain is a mapping between a user ID and a list of post IDs ranked in the order that you want to show it to the user. I have a question mark over here because of course the big question is going to be how do you populate this cache? And we're going to talk about that in the next 2 or 3 slides. For now, just think of the population part as a black box. All you care about is this cache and what it contains. So what the cache is going to contain is a mapping between the user ID and the list of post IDs. Of course, you can ask that why only the post IDs? Why can't we just store the whole post? That is, of course, to save both on bandwidth and also storage. You don't want to store the whole post object for every single post. In our case, of course, the post is simple, where it has a description and a photo. But you can imagine a post object being much more complicated, and making that one request to get all the post details about from a post ID, that is not super complicated. So I think in our case, we can still do that. The more complicated part, which was to create this mapping, right? So creating the mapping for user ID to a list of post IDs ranked in the correct order, that was the more complex bit. All we're doing is now taking all those complication, abstracting it away, and then putting the mapping in this Redis cache. Now, whenever the user makes a call to the feed service with the user ID, all the feed service does is gets the list of post IDs from the cache, which is very quick, and then makes one HTTP call to the post service, giving it all these post IDs and getting the post metadata back. Once it has all the post data, it goes ahead and sends it to the client. So you can see how we, give me 1 second, let me just make sure this is, yeah. So you can see how we moved all these things, all the database queries, all these HTTP calls to just one cache where everything is there in the cache for the feed service to just serve the user. This way, we drastically reduced the amount of work that the feed service, as well as all the other services, have to do when a user requests their feed, right? Now let's focus on the next bit, which is going to be the question mark you see over here. This is going to be related to how do you actually populate this cache, right? We can see the benefits of having the cache, but of course you need a good way to populate the cache. Otherwise, the user's feed might be outdated or they might not be getting the content that they would enjoy. Okay, so this is gonna be, I think, one of the more dense slides related to the population of the feed cache. So on the top over here, the flow you see, this is exactly what we already talked about, where a user is creating a post, it's hitting the post service, and then of course, once the post service is storing the post in the database table, you have a CDC stream, and then you had all those stream processing jobs trying to like moderate the post and enrich the post. Now you add another bit to it, which is gonna be this new feed stream processor. This is gonna be, of course, another processor, so you can have a bunch of workers listening to this CDC stream and accepting a payload for every single post that has been created. So for every post that has been created, you are gonna get a message in the CDC stream here. And then your workers, so in this case I have one, but of course you're gonna have multiple copies of this processor running. Your worker can independently pick up these posts from the CDC stream. For that post, it can talk to the ranking service, the feed service, the post service, all those things to populate this post into the feed of all the users that should see the post, right? So let's say for a given user, if they have 10 friends, the feed stream processor is gonna take in the post that the user created, talk to like the feed service, the ranking service, even maybe like the friends service or any other service we might have. But essentially what it's gonna do is figure out who should be shown this post that a user just created, form the whole feed of those users, and then store the user to post mapping in this feed cache, right? So to recap whatever I just said, all the stream processor is going to do is take in every single post that was created, figure out who else this post should be shown to. For those users, go ahead and recompute the feed of that user, now including this new post that was just created, and then stick that mapping between the user ID and the list of post IDs to the cache that we were talking about. This is the same cache that we were talking about over here. So this way, the cache gets updated for every user, whenever there is a new post that the user should see in their feed, right? The whole thing should be done in real time because we can easily scale up the number of workers for the stream processor. So every time a user has a new post eligible to be shown in their feed, the feed stream processor should know that and then stick that post ID in the Redis cache related to that user. And then going back to the previous slide, the feed service for that user can just get the new data from the feed cache instead of needing to do all the different HTTP calls and computation. So that's going to be the first real-time pipeline where we can populate the feed cache. Apart from that, you can also have more of a batch job. This is going to be like a scheduled job. It can be like a Spark job or some kind of an offline system, which iterates through all the users who you need to update the data for. And then it can go ahead and do the same thing that the stream processor is doing, but do it on a more periodic basis rather than in real time. and it can go ahead, do all the different computations, HTTP calls for every user, find the list of post IDs that should be shown in a user's feed, and then stick them into the cache over here. So essentially you have two systems. One is going to be real-time. That's the feed stream processor. This is going to be based on the CDC stream coming from the post table. And it's going to make sure that for every new post, it reformats the feed for users that should actually see this new post, and then put it in the feed cache over here. And then you have the other more offline and scheduled job. This can go through all your users and recompute their feed cache every single time. You can get by with only having a scheduled job if you don't care about the feed being real time. But more often than not, of course, I think you would want to have a real-time feed system. That's where the stream processor comes in. All right, so putting all of those together, we're going to look at both the use cases together now. So the creation and the consumption. For the creation bit, the user is going to open their app and create a post. The app is going to hit the load balancer, and the load balancer is going to call the post service. The post service in the HTTP request, it's going to find all the data related to the post. It's going to go ahead and store that post in the post table and store a mapping of the post to the user in the post user table. Now you have this offline CDC stream that is based on Kafka. What the CDC stream, what the stream does is every time a row changes or a new row is added to the table, it has a Kafka message in that topic. You can have different stream processors that are going to be listening to this Kafka topic so that they get notified whenever a post is created or a post is updated or even deleted. You have two stream processor job over here. One is moderating the post, so it makes sure that the post is not inappropriate or illegal. And then you have another enrichment stream processor. This is extracting all the different metadata and enriched data about a post and storing it in some other database. Both of these are happening in real time. And of course, given the volume of post creation, you can scale the processors up and down. Now the next one is going to be the feed stream processor. Similar to the other processors, this also gets the information about a new post the moment the post was created. What the feed stream processor is going to do is for that new post that was just created, it's going to figure out all the different users that this post should be promoted to. To do that, it's going to talk to the ranking service, the post service, and even the feed service. Once it figures out all the posts that the user should be shown, including the new post, it's going to store that mapping in the Redis cache we're calling a feed cache, which is owned by the feed service. Now, for the second bit, whenever a user opens the app to consume the posts in the feed, in their feed, we're going to make a GET request to the feed service. All the feed service is going to do is talk to the feed cache, get a bunch of post IDs. It's going to talk to the post service, so the service over here, to get the details about all the posts, and then send all the posts back to the client. Offline, you can have another process, which is going to be a scheduled job. This is going to iterate through all the users in your app and reformat or recompute the feed of that user and stick it into the cache too. So you have a real-time system happening based on the CDC stream and the feed processor. And you have a more offline system, which is going to be a scheduled job doing it. But regardless, getting the feed should be very, very quick, because on read time, so when the user makes a request to get the feed, you are not doing any complicated computation. All you're doing is reading a mapping of a user ID to a list of post IDs, getting all the post details from a post service, and then returning it back to the user. So hopefully this gives you a good idea about how a relatively scalable newsfeed system would work. Of course, in our system, we assumed that the post data model was pretty straightforward, and we also acted on the basis of a friend, like a user friend model, but you can easily adapt this to whatever different or slightly tweaked version of newsfeed that you have. So hopefully that was helpful. If you have any questions, let me know in the comments below, and I'm gonna get back to you as soon as I can. I am gonna try to add a few other resources about some more advanced topics when it comes to the system design. I tried to keep the design as basic as possible, but if you want to learn more about the different details, I will have a few links that you can take a look at to kind of give you some more information about the system. So with that being said, the next few videos are gonna come out in the next few weeks, so please do subscribe and like the video if you are interested in the content. And with that being said, I'm gonna catch you guys in the next one. Bye-bye.